Okay, so let's find out what is a potential due to a point charge. Or in other words, we have a point charge of plus 1 coulomb as shown here. And when we move it in an electric field generated due to another charge plus Q, capital Q, let's study what is the potential in this case. Let's say I'm moving this positive charge plus 1 unit charge from infinity position towards Q in the electric field created by Q, and let R be the position vector, let Q be the origin for the position vector, and R is the position vector, and this is the direction of the position vector. So when I am moving the positive unit charge in the field towards Q from infinity, this is the direction in which I am moving. So this is a negative direction as far as R vector is concerned. Let's keep that in mind. Now we know that the electrostatic force acting on this unit positive charge is given by k q1 q2 by r square, or nothing but k is 1 by 4 pi epsilon naught times q, which is the positive charge capital Q, times 1, which is the unit charge, divided by r square, which is the distance in the direction of r vector. Okay, so now we know that the work done here is negative. So if we want to find the work done, this is the electrostatic force. So and if I move this a distance delta r, small r, delta r in this direction, delta r is negative in this case. So the force times distance is work. We know force times the distance is work. So the small amount of work done, or delta W, is given by 1 by 4 pi epsilon naught times Q by r square into minus delta r. That is why work becomes negative in this case. To get the work done, we can integrate this, and by integrating from infinity to r, 1 by 4 pi epsilon naught q by r square dr. So when we integrate 1 by r square with respect to dr, the rest is all constant, we get minus 1 by r. There is already a negative sign here, and this minus 1 by r and the negative sign become positive. So we get q by 4 pi epsilon naught 1 by r from infinity to r. So when we substitute r, we get 1 by r, but when we substitute infinity in place of r, 1 by infinity becomes 0. So in the end, we get q by 4 pi epsilon naught 1 by r, which is q pi 4 pi epsilon naught r. Now by definition, this work done in moving a unit positive charge from infinity to a point is called the potential. The potential at a point r is given by q by 4 pi epsilon naught r. This is the potential formula. Thank you.